Welcome, ladies and gentlemen, to Integrated Math 2. In today's episode, we will be discussing Chapter 8.4.1, which is a special ratio. We're going to first start examining number 8-77, which is a polygon with infinitely many sides. And what we're going to do is we're going to predict the area and perimeter of a polygon with infinitely many sides. And we're going to work with other teams to generate data from different polygons, and then we're going to start looking for a pattern here. And so most important thing about this problem is that they want the radius of the polygon to be 1 unit. Now the radius is going to extend from the center all the way out to one of the vertices. So if you look at this pentagon right here, the radius is 1 unit. And we're going to be using a calculator for this. So I have my trusty calculator at my side also, so you'll hear some button pushing going on my end as well. And so from here, we're going to just slowly start building the number of sides, and we're going to see what happens when we approach infinitely many sides. So let's just do a couple. I'm not going to do all of these for you because it would take a lot of time. That would be 12 problems, and I think you guys would eventually kind of get to see the pattern here. But we'll start with an equilateral triangle here. So let's find the perimeter of an equilateral triangle and the area of an equilateral triangle. So from here, if this is going to be 1, right? From here, I know a couple things about this equilateral triangle here. I know I can extend this down and make this a 90-degree angle. Each angle in an equilateral triangle is worth 60, making this 30. And making this 1/2, and then down here is going to be root 3 over 2, or 1/2 times root 3, for those of us who want to be a bit more literal with it from what we have in Integrated 2. And so what I'm going to do is I'm going to go ahead and do, let's find out how many small triangles there are going to be in here, right? And so from here, that would be another one. So that would be 1/2 base times height times the number of triangles that there's actually going to be. So that would be times 3, right? And so from here, that would be, the area would be 1/2 base. So that's going to be, this entire thing is going to be root 3, because if I multiply this piece by 2, the 2 and the 1/2 are going to cancel each other out. I'll even show it to you. I'll multiply them by 2. That makes them go away. So my base is root 3, and my height is going to be 1/2, right? So 1/2. So let's find out how much that is. That's going to be the square root of 3 divided by 4. So square root of 3 divided by 4, and that is going to be 0.433. Cool. So now from here, let's find out what the perimeter is going to be. That's going to be rad 3 times 3 of those sides. So that's going to be 3 rad 3. So 3 times the square root of 3. That's going to be 5.196. So that'll take care of A. I'll go and take care of B real quick, a regular octagon. And so from here, I'll go and draw as best I can a regular octagon. Let's see, 6, 7, and 8. Awesome. Okay, so again, what is the characteristic about this octagon? Is it has a radius of 1 right here, which means this length here is 1. I'm going to eventually split this up into 8 triangles, the way I have been with all of my areas of polygons. And here we go, and here we go, and here we go. So let's go and talk about what I'm going to do here. The area is going to be 1/2 base times height times the number of triangles here. So the number of triangles is going to be 8 triangles. I don't know my base or my height yet, but what I can do is I can go ahead and find out what the base is. How do I do that? Well, the first thing I'm going to do is I'm going to find out the total angle sum of this octagon. That's going to be n-2, or 8-2 times 180. So 180 times 6, which is going to be 1080. But I'm going to go and divide that. So one angle is going to be 1080 divided by 8. So I'll go and divide that guy by 8, which makes each angle 135 degrees. Now, I am going to divide that in 2, because this is going to get me only partial of the shebang right here. So 67.5 is the measure of that angle. I'm going to go and bust him out just a little bit so I can work with him a little bit more clearly. And so from here, this guy being 67.5, this guy being 1, I've got to solve for x and I've got to solve for y. Let's go ahead and solve for y first. That's going to be opposite over hypotenuse. So I'm looking at a sine relationship of 67.5 equals y over 1. So let's see what mode I'm in. I'm in degree mode. Good. So sine of 67.5 degrees is going to get me y being 0.923. And then my x value is just going to be cosine of 67.5 equals x over 1. So I'll go and do cosine of 67.5. And I'm going to get x equaling 0.382. Okay, so now from here, my height is pretty clear. It's this 0.923 number, so 0.923. My base, on the other hand, is going to be this 3.82 number times 2. So that's going to be 765 right there. And let's go ahead and figure out what this is going to be. So I'm going to multiply this 0.765 by 0.923, and then I'm going to divide them in half. And then that's going to be multiplied by 8 total triangles. So that's going to be, my area is 2.8257. Now from here, if this base in and of itself is 0.765, then if I just take my 0.765 and multiply them by 8, my perimeter is pretty easy to find. It's 6.12. So in this case, in B, I've accelerated the number of sides that I've had by a lot, and so it makes sense, hopefully, that the area and the perimeters would have changed in tandem pretty drastically. So let's see what happens if I get a 30gon in here. So I'm going to go and do that next. 30gon. I don't even want to attempt to draw a 30gon, so I'll go and call this C. So a 30gon. And so I'll just go ahead and just do this real quick. So from here, I like to draw the base of it. That way I know that at some point something is coming down which has a length of 1. And I know I'm going to be making another right triangle and doing the same process over again. So let's go ahead and do the total angle sum. The total angle sum of a 30gon. So that's going to be 30 minus 2 times 180. So that's going to be 28 times 130. Oops, 28 times 180. Sorry about that. So that's going to be 540. So total angles is going to be 5040. But that's all the angles, though. I only want one of them. So one angle, I'm going to take my 5040 and divide it by 30. That means that each angle is 168 degrees. But that is the entire shebang right here. I only want half of the shebang. So I'm going to take that 168 and divide it by 2. So that means that this angle here is 84 degrees. Now again, I've just created not a special, but just a right triangle here. I'm going to use sine and cosine to get x and y, just like I did with the octagon here. So sine of 84 is equal to y, which is going to be equal to sine of 84. That's going to be 0.9945. And then cosine of 84 is going to be the x over 1. So if I do cosine of 84, I'm going to get 0.1045. And so again, what we're going to do is we're going to do area is equal to 1/2 base times height times number of triangles. Now in this case, there's going to be 30 triangles. My height is going to be 0.9945, and my base is going to be this number times 2, because again, it only covers half of that base right there. So 0.209. So I'm going to take that and multiply him by 0.9945, multiply him by 30, and then divide him by 2. So it looks like I'm getting 3.118 for my area. And the perimeter is going to be, looks like this number here, so this 0.1045 times 2. That's going to give me the whole thing. Now I'm going to go and multiply him by 30 and see what happens. I get 6.27. So as you guys continue working on this, as you guys extend towards a 180 gon, actually, why don't we go and just do the 180 gon? So again, I'll go and draw this figure right here. So a 180 gon, I'll just go and draw his base. I'll go and move through them a little bit fast. So the total angles in my 180 gone. So that's going to be 178, or 180 minus 2. 180 minus 2. So that's going to be 180 minus 2 times 180. So 178 times 180. That means that my total angles of a 180 sided polygon is going to be 32040. I only want one of those angles, so I'll divide by 180. So each angle is 178 degrees. But then the half angle is going to take that and divide it by 2. So that's going to be 89 degrees. So that's going to be like that. So now I'm going to go ahead and draw this guy down. Y, x1. So sine of, 89 is equal to y. Cosine of 89 is equal to x. Let's find out what those are. So that's going to be 0.999. And then cosine of 89, sorry. 89 is going to be pretty small. 0.0174. Okay, let's go and do 1/2 base times height times number of triangles. So the area is going to be 1/2 base times height times number of triangles. In this case, it's going to be 180. My height is going to be 0.999. My base is going to be this guy times 2, right? So times 2. So putting it into here, I got to multiply by 2. That way I get the whole base here. That's going to be 0.349. So let's go ahead and take that, divide by 2, multiply by 0.999, and then times 180. This is going to be 3.138. My perimeter is going to be double this guy, so 0.349 times 2 times, how many? 180? Just realized I made a mistake right here. This is 0.0349. So now what I'm going to do is I'm going to take that number, so that's 0.0349, which is the entire base of this 180 sided polygon. And I'm going to multiply him by the number of sides he has. He has 180 sides, and I end up getting 6.282. Now, these numbers should start looking familiar to you, especially as we start to add more sides. We're getting close to an irrational number that I'm hoping you recognize, and this number seems to be a little bit more, kind of like double what that area is. So I'll be back with the next problem, and if we see if we can establish that pattern. Be right back. In 8-78, we are going to analyze this data, and it says, with our team, we're going to analyze the data collected by our entire class. And so as we approached so many sides on this infinitely sided polygon, what will we predict the area for the regular polygon with infinitely many sides to be? Well, it seems like it's approaching 3.14 with more decimals attached to it. There always seems to be this irrational number, and this number should look familiar. We know this as pi. And, so I'll call this the area here. The perimeter, on the other hand, ended up being like 6.28, which ends up being 2 pi. That ends up being your perimeter. So from here, we will eventually extrapolate the formula for the area of a circle and the perimeter of a circle, but we'll do that in just a little bit here. It says, what shape does the regular polygon with infinitely many sides resemble? Obviously, I just kind of spoiled that. It's going to be a circle. It's going to be a circle. And then does 3.14 look familiar? We just talked about that a few seconds ago. 3.14 ... is equal to pi. And then 6.28 ... is equal to 2 pi. Okay, let's move on to the next question. Let's move on to what the area and circumference of a circle actually are. And so it says here, what is the relationship between any two circles? Explain how you know. And so the relationship between any two circles is that, where is that A? Yep, right there. Any two circles are always similar because shrinking or enlarging the radius makes the points still equidistant from the center. So one of the advantages of a circle is that they're always similar, which helps us when it comes to solving problems in similarity. So it says, refer to the circles at the right. What are the ratios of their circumferences and perimeters? And so what is the ratio of their areas explained? So let's talk about how to find the circumference of a circle. The circumference of a circle is equal to 2 pi times r, which r is the radius. The area of a circle is going to be pi r squared, where again, r is the radius also. And so when you look at the circle on the left, so the left circle versus the right circle, let's take a look. So it looks like the scale factor of the radius is 3. So the circumference being the perimeter of it should be the same. So let's see if that's true. The left circle, the circumference is going to be 2 pi times 1. The circumference of the right circle is going to be 2 pi times 3. So 2 pi versus 6 pi. So yeah, our scale factor for the circumference is 3, and we saw that happen in the last chapter where the perimeter's scale factor was always the same as the linear scale factor or the side scale factor. Let's talk about the area. So the area of this is going to be pi times 1 squared, which is going to be pi. The area here is going to be pi times 3 squared, which is going to be 9. And so I'll call it linear scale factor, our area scale factor is going to be 9, right? Because pi versus 9 pi, there it goes. So there's that area scale factor again, which is basically 3 squared, which is just like your linear scale factor being squared. It says if the area of a circle with a radius of 1 is pi square units, then what is the area of a circle with 3, and then 10, and then with r? Okay, so we kind of answered that already. So with C, let's say if the radius, if r equals 10, so we should see this, let's see, we would have the area being pi, so pi times r squared, which is going to be 100 pi. And then the perimeter, or the circumference, would be 2 pi r, which is 2 pi times 10. So that's going to be 20 pi. It says likewise, if the circumference or perimeter of a circle with a radius of 1 unit is 2 pi units, what is the circumference of a circle with a radius of 3 units, and then with 7 with r? And so from here, let's see here, what is the circumference of a circle with 3 units? So if r equals 3, then we have the perimeter being 2 pi times 3, which is going to be 6 pi. If r equals 7, it would be p equals 2 pi times 7, which is 14 units. And then if the radius was r, it would be 2 pi times r, which is going to be 2 pi r. So there we have it. There's how we find the area of a circle and the circumference of a circle. Make sure these formulas are kind of kept in your memory bank right there. That way we can use them readily whenever we need them. As always, please leave comments or questions in the comments area. I will see you all in the next episode.